Hello, good morning. My name is Andreu. I come from the Universidad Politécnica de Valencia. And now we are going to start with the first technical session, that is the session related with the DataPorts platform. My role and the role of my group, that is UPV in the project, is the lead the implementation of the platform and, in addition, the dissemination activities. For that reason, my colleagues, Matilde, Julian, Alexandros, and Miguel, are going to introduce the several building blocks of the platform. But this is from the technical point of view. But in addition, as I said, we are the communication managers. In the website of DataPorts, there are a lot of material that you can find more information about this platform. Our platform is composed of several building blocks. And Matilde is going to introduce the data access and the data processing services. Alexandros is going to focus in data governance services. And finally, Miguel is going to show you the analytics services. Only to say that if you have any questions, we are upstairs and we can explain to you anything else that you want to know about the platform, or we can contact via the social media, online, or whatever. And now, I'll pass it to Matilde.
Thank you. So I'm Matilde Julian from UPV, and I'm going to present the data access and data protection of the platform. So as data saying the sessions, there's very little that we don't have data. We have tons of data currently, but we need to find a way to manage it because this data cannot be centralized at this point. There are different ways to access the data, different data formats, different technologies, and different vocabularies. So we need to find a way to make it to this interoperable among different ports, different platforms, different companies. That's where the role of the data access and data processing services of the platform. Here we have three blocks which will make take the data from the different sources and make them available and understandable for the services that we have on top, and also other services can be built directly on top of them. Here we have the data block. The data block, which is the lowest one, and closest to the data sources, and deals with the communication between the data sources. Next is systematic interoperability, and provides a common vocabulary to make the data understandable by the different data consumers. And the data abstraction, which processes the data and stems from the data analytics services that can be on top, and also for the ones of the data data. We need to know detail. The data access component starts from the blocks. One of them are the agents, which are built specifically for the data source, because the agents deal with taking all the data from the source and converting it to a common format that can be understandable on the platform. And then we have the data access manager, which is a tool that provides a user interface and API to manage the data access manager. You can create an agent, run an agent, stop an agent, and so on. Closely related to the data access is the semantic interoperability component, which is going to provide us with a common API to access all these real-time and historical data that the agents are getting from the platform, and also a vocabulary to make all this data understandable in an end using a common data model. And also the metadata from the data sources that is going to be useful for the data governance in the to give the permissions and for the data analytics services to know what is the data. And Finally, our final work is the transaction and virtualization. So really possible is upside down the data abstraction and virtualization. Is the historical data from the semantic interoperability and Prodevelop is going to process the data. This processing is going to deal with incomplete values, erroneous values like not a number or unknown type of data and duplicates in order to provide the quality of data possible for the data analytics. Then it has the virtual data repository, which is a data lake basically. This is a temporary storage because the historical data can be very big and it's going to speed up the process from the data analytics point of view. And finally, we have the virtual data containers. We provide the data to the services built on top and provide a standardized file capability in order to allow the data analytics services to select the interesting data from our list. So the benefits of the data access and data processing services are the first one, interoperability, because we don't have to deal with the different formats, APIs, and types of data that we have. You have a common way to access data and a common data model for all this. It's easy to use and deploy because it can be deployed on Docker. And also it's modular, you can deploy it on premises or in the cloud, on premises and part in the cloud. Okay? And you can scale it up if you can duplicate one of the components and can manage it and run them in parallel to speed up the process. It requires less effort because the data is standardized, so are the APIs, and also the data access manager provides templates to help you develop the things. And finally, it's fully compatible with Firewall ecosystem because the format that we are using is NGSI, the same as Firewall, and we have based our data model in the Firewall smart data models and other common version software. So that's with the services, thank you. And now Alexandros is going to present the Explore. It's that freelance.
Hello, my name is Alexandros. I'm CERT, the Center for Research and Technology in Greece. And I'm going to talk a bit about data governance. Data governance is a mechanism that enables the enforcement of access rules to business data, which for us is the different data sets available in a transparent, verifiable, and non-repeatable way. Data governance increases the consistency of and confidence in the registered data, all the while ensuring data sovereignty. The five areas where data governance makes its impact felt is quality, so making sure that the data is described in a consistent way. Knowledge, making sure that data is easily searchable. Ownership, making sure that the provider always has the ability to full ownership. So, for example, has the ability to revoke access, but also on the other hand, making sure that there is a mechanism for sharing agreements to be pleasant and be agreed upon by provider and consumer. Accessibility is another area where data governance makes sure that the user knows which data sets are readily available in the platform for him or her to use. And security, making sure that all the information I just described is kept in a transparent, verifiable, and non-repeatable way by using blockchain technology. So the the highlighted boxes where data governance lies, the same picture that we saw earlier. It communicates with both data processing services and analytic services to pass on permission information, permissions of users of datasets, and also metadata information. This is the components at a glance. We have organizational users that use the data governance front end, which talks directly to the REST API we have implemented. On the other hand, we have other DataPorts components that can also interact with our backend through the DataPorts API gateway. In essence, what the gateway does is it acts as a proxy for our REST API. In both cases, the end result is that by using the REST API, in essence, we execute blockchain chains. So this is the code that makes sure that everything is verifiable, non-repeatable, and so on, which is our backend running in Hyperledger Fabric. That's where all the metadata is kept, the sharing rules, and so on. Now, through data governance, we can describe the dataset through metadata, define access rights for a dataset, search metadata, request access to existing datasets, revoke access to datasets. This can be done by the provider, but also the consumer can ask for a revocation at any point. And also be able to view what close registration and access to datasets. The demo scenario that I'm going to show shows the Thessaloniki Port administrator logging in and entering the metadata for the new dataset. Then we have, for example, the Valencia Port administration logging in and creating a new user. And then this user in turn logs in and searches the metadata for a suitable dataset, proceeds to ask for access for this specific Thessaloniki dataset that was created in the beginning. And finally, the TSPA admin logs in, reads the access request and accepts it. Currently, and demo. So which one should I use? The first one? This one? Okay. So, history has been logged in, I'll zoom with the data. Login screen. We have the menu at the left, goes to internal dataset, which means the dataset that it is created that belong to PHPA. Click on add the dataset, and here the administrator fills out all the necessary fields to describe the metadata, like distribution, for example, it's in a CSV Excel format, and saves the metadata. Now, check the case agent is checked, but no data source ID is chosen. This means, let me explain this. What this means is that the metadata has been created in data governance, but for the time being, there is no connection between this metadata and the data available through the data access component, the agent that Matilde was talking about just earlier. It's important, and that's why I said earlier that data governance offers the ability for the user to know which datasets are readily available. Once this box is not orange anymore, so once we have provided the data source ID, meaning we have provided the connection to this agent that reads the data, the dataset is, the user can know that the dataset is readily available. And this is what we will do next. So initially the without this data source ID, at a later stage, the administrator logs in again and now provides a data source ID, meaning the agent is ready and running. He selects from the correct ID from the list and saves the changes. Now we will see his agent is true, the data source ID, you can see it there, and in the list now it's not orange anymore, so we know everything is set up correctly. Now the VPF admin logs in and creates a new user to handle PHP data. Let's say this new user is going to be specifically created for handling data from the Thessaloniki Port. We add this user. This is a normal user, not an admin. We give her a name. Well, not the Spanish name, but anyway, still use a name. We register the user. And we get the initial password, which we use at first the login. This user logs in, sets the metadata, and creates an access request. So here we are, the password that we copied. Initially, we had to change this password. Okay, now we go to search the datasets and we select specifically, first we select those that don't have an agent, but then we decide we do need an agent to be connected to the dataset, so we need readily available datasets. And from those, we select this one. We choose to the modify request. So, and we click on personal request. So now we have requested read and modify access to this dataset. The write access includes the read access. Okay, now the TSP user will log back in at the later stage, let's say, and will accept the request. He goes to notifications and sees there's a new notification for an access request, sees the details that it comes from VPF from the user brown name and accepts it. Notification is removed. And now, going to this particular dataset, we can see in the permissions tab that indeed this user has modified permission for this dataset. The user from VPF logs back in again and checks from his whether everything is okay with her application. Here we go to external data, meaning datasets that don't belong to VPF that we have applied for access to, and indeed here it is, we have access to the dataset, and in the access history we can see that we asked for this particular permission, we got it this particular date, and everything is fine with respect to this dataset. That was my demo. Thank you very much for your attention. Miguel will now present the analytics side of things.
Hi, hello everyone. I'm Miguel Bravo. I'm the data scientist at ITI. And I was one of the main developers of the artificial intelligence component. And the analytics analytics services are located here. I can understand how to manage this. Yeah. Okay. And this is okay. That's what I wanted. And the services are there's the team and the architecture, and they are collaborating with. Yes. That's working. Again. Yes. Yeah. Again. It's back. Back to the bar. Okay. Just check things in case. Yes. Is it? Okay. Should I just double check? Can you hear me from home? Anyone, please? Yes. Yeah. That's it. And I'm open, right? Well, we thought about some of the technologies implemented in the data analytics service component, and as I would like to not talk about technologies and techniques of pipelines and so on, but to give you a real live demonstration so you can see with your own eyes and understand how the components analytics component work. It should be dynamic, but in any case, I'll try to explain you as fast as possible. The use case is about training a new cognitive service. Let's imagine that we're a professional working in port, and I would like to extract insights from my data utilizing artificial intelligence algorithms. And in that case, I will use this component specifically as a user to create a new cognitive service. For that, I'll show you later the live demo, but for you to understand the pipeline I'm going to follow. In the first case, the user starts the creation following a wizard. Internally, the component called automatic model training engine will configure a data parameterized data pipeline, selecting a collection of machine learning models and several optimization techniques, data pre-processing, and so on. Then once the training has been started, the data will be requested to data access component, and so data structure and visualization will process it accordingly. After that, machine learning models will be trained in parallel, all of them, the whole collection. They might range from several of them to a handful of them to hundreds of algorithms, with the aim of obtaining the best predictive model possible with this data. Once the best model has been found, the real-time data will be captured throughout semantic interpretability component in order to perform new predictions in real time. For that, I will show you specifically how the component looks like. It's of course friendly, easy to use web interface, and then in this case, you can imagine, we introduced some security in the component, so not any person can log in here. So I taking up the challenge of making a live demo. I hope everything works. Because, not every time things work as expected. So in order to see how it works from the get-go to the end, all components in the DataPorts should work. So let's cross fingers. This is the user interface. This is the creation tab of new cognitive services. Right? Well, it's a guided wizard. We should have just to follow several easy steps. First of them is to introduce a name for the service. Let's imagine I want to see the congestion of the port of Valencia in the next 7 days, for instance. And just copy and paste that in the description. And I'll choose from one of the 6 available types of cognitive services, from product-related cognitive services to ports-related, congestion, occupation, when the vessel is going to arrive vessel is going to depart, and so on. In this case, the specific cognitive service is the vessel port calls calculator, which calculates the amount of port calls expected in the future to arrive to one port, several ports, one terminal, all of the terminals, and so on. For that, I click on that. Then I select the dataset, specific datasets, dataset related to this service, which is the PCS port call dataset, which is already pre-processed by data structure virtualization, of course. And then here, the user will be able to specify, to fine-tune the cognitive service. In this case, I want to see how many port calls will be expected in the port of Valencia in all terminals or lines in the next 7 days. Then, I click next. I have the option to choose between different training strategies. Well, from the fastest one to the most complex one. I will just choose standard and confirm that everything is all right. And here in this new tab, service tab, I can see all the services already trained, plus the new training service. When it's done, when it's finished, I will be able to deploy it and see the results. Right? So we trained already a cognitive service. We will leave it here, and the backend, it's already training in parallel the machine learning algorithms with the data selected. So hopefully it will convert somehow. Now I'm gonna move on to the next slide I wanted to show you, which is the continuation, the logical continuation of the pipeline of a professional in a port utilizing this component. Now, once that we have several cognitive services trained, one of them, for instance, will give us the time when arriving new vessels will depart from the port, which is very interesting from the business point of view. So in this case, we'll have different vessels arriving to the port with different stages, from estimated vessel to authorized operational and completed when the vessel left already the port. Thanks to our already trained model, we will have to make best predictions to predict the time of departure, the potential time of departure of the vessel based on the historical data used to train the model, of course. If the data changes, the predictions will change accordingly. Therefore, for that, I'll go back again to the automatic model training engine web user interface. It should be here. You see? Thanks to the big infrastructure we are utilizing to process and train the models, the cognitive service converged when I was talking. So I am able to deploy it. What does it mean? It means that here in the tab results, the results tab, I will be able to analyze all the results outcome from all the services. In the first place, we have the service that I just explained in the previous PPT, which is the one related to when vessels will depart. Here we can see currently in real time all the vessels that are estimated to all ports of Valencia, Sagunto, Gandia, and Valencia. All estimated vessels that are not only estimated but authorized, operational, and completed. PCS calls is represented here in this screen. Right? Of course, as a dynamic table, I'm able to filter wherever I prefer the most. Well, what can we see here? We can see here the departure column, which is the most important one in this case, because we are not seeing real departure times, but predictions made by our cognitive service train. Those are just predictions. Expected times of departure. And above that, on top of that, we can see a parameter we call deviation from reality, meaning that how different are our predictions compared to the real time of departure of vessels, right? So if we go here and we filter, we see just completed vessels. Here is the real departure time of the vessel. We compare that with our predictions, and that's how we estimate this parameter. So it's not far from reality, which means that it's quite acceptable, to be honest. And if a new vessel arrives, it will be shown here immediately. Okay, but of course, not all the time vessels are arriving to the clear. We will have to be very lucky in that. So going back to results, I will just go quickly through other types of cognitive services for you to understand what can we do with this component. We can see this is the service I just created, congestion of the port of Valencia in the next 7 days. Right? So this is historical data in black color, and those are the predictions for the 7 days. So we are expecting a decrease in the number of vessels arriving to Valencia, the port of Valencia, but then it will rise up again at the end of the day number 7. You see, let's zoom out, see the overall historical data. Well, similarly, we have other type of cognitive service, such as the average of the berthing time of the vessels in port, in a terminal, and so on. Again, we can use our crystal ball to see how in the future this parameter will perform, will behave. But not only we have services for ports, but also for products where we can analyze how different products will behave in the near future. For instance, we will be having services based on custom trades and in the Spanish customs agency, actually, where we can analyze how animal products will be imported into the district of Valencia in the next 3 months, for instance. So we see the progression here in the near future in the next 3 months. And in addition to that, actually the country shipping animal products is good to Valencia as a country, right? So those are the most representative countries importing or exporting from their side animal products. Additionally, on the right-hand side, we have a similar service, but not based on the customs agency, but on the PCS traceability dataset, which is a mixture of some of them, and analyze similar parameters. That's the progression in the near future, how it's expected to behave in the future, and additionally to that, some analytics. These are real analytics of different products in percentage imported to Valencia. Okay. And last but not least, missing value service, which means that this is a service that is able to impute missing values in data sets from the port. That's another business KPI we analyzed, and this is able to impute, for instance, in this case, missing districts in a certain data set. So we can see here that Madrid got the most imputed missing district for Valencia, Barcelona. Okay. So I think this is the end of the presentation. Thank you very much, and I hope you enjoyed it. Thank you. Any question, by the way? Let's move to the pilots. So, should I forward? Okay, so I think there was some conditions and no sense.
Good morning, I'm Pablo Giménez from Fundacion Valenciaport. Now let's start the pilot session, starting with the Port of Valencia. We're going to see the use cases of we define it for the port. Together with my colleague Miguel, and I will explain the different use cases. So let's start with the first use case, the tracking of transport operations. As you know, in transport operations, we have freight forwarders that are managing the operations on behalf of importers and exporters. We have on the other side the shipping lines that provide the containers for these operations. And for these companies, it's not easy always to get data or real-time data of the goods, their containers, and even sometimes they have to get this data by phone calls or emails. Something that is quite difficult if you are managing a big amount of containers. In order to help them, we integrated on DataPorts different data sources. You can see here some examples. We have data from the trucks entering and leaving the port from the Port Authority of Valencia. We have also from Posidonia vessel locations when they are close to the port on the AIA signal. We have also from TrackSense the container location, not only the location, we have also air fencing, we have also opening. We integrated also e-forwarding. It's a freight forwarded platform, which is used by a big amount of companies, and they use for their daily operations. So they are also providing interesting information. And finally, we have some road transport operations from the business. With all this data, we deploy this implementation. You can see on the left side the data sources that we just saw. They are sending real-time data to the DataPorts platform. You can see here the DataPorts components that we are using. I don't will focus on them because you already saw them in the technical session. And on the other side, we have our tracking application, which is receiving, subscribe to receive all of this data. Here you can see a screenshot of the application. I'm not going into details because we will see a live demonstration just. Before that, only mention which are the benefits we saw for this application. DataPorts is going to provide a single access point for all kinds of events and information. We have data in several platforms, so it is not easy to access all of them. So in this way, we have an only access point, and also we avoid different authentication mechanisms. In addition, as we are using DataPorts common data model, it's easy then when we have all the data to integrate in all applications. So as a summary, we are using DataPorts as a common platform for gathering all the data and also for accessing. Okay, so let me show you the real application. Okay, once we access in there, so I need to log in again. We have a logistic tab with different views. We have segments as global view of all this information, and we can see the different systems registered right now. We can see, for instance, this one is a multimodal transport, which is in execution. So we will have partial information right now, but we can see it's a transport from Silchar. We can see here estimated and real dates to Miami, estimation of 5 pallets of tags. If we open it, we can see the individual messages that are composing all this segment. We have the segment request, the segment plan, the paid out, the pickup, all the information that we are receiving from the different companies participating in this segment. We can see another example which is finished. For instance, this road transport from Zerzelidis to Valencia, to the port of Valencia. In this case, we have more information because it's finished. So we have the real data for both them. The transport unit, which is the container we are using, the type of container. Information about the gate out, where we pick up this container, and also the victims when it arrives to the port. And as before, if we open it, we can see the individual messages that compose all this information. Additionally, as I said, we are integrating before warning. So we have, if we saw the last days, the last shipments, we can see this one is a palette of some documents sending from India. So we can see real-time information that they are managing in the plant. As I said, in Siemens view, we have the global information, but then we have other views with partial information. For instance, for Siemens that are multimodal with different transports, we can see the individual transport of each of these the parts of the Siemens. We can also see the view of the transport units, of the list of containers used in that Siemens. We can see the gate in and gate out orders of these Siemens, because it's relevant to have separate to see them. And finally, we have the individual events that are sending the companies to complete that Siemens. In this view, we are also integrating the data sources that I mentioned before. So we can see, for instance, the trucks that are leaving the port. We open them, we can see some minutes ago, this truck container, it's in someone else. This truck with this container leaving the port, we can see the lane of the exit and also the time when it is coming. We can see also information from Posidonia. So we can see, for instance, this vessel with this number, which is in this location. Here in the port. Or let's see another one. Another place. We have also information from tractions related to containers. So we can see, for instance, this container is currently in this location since today.
¿Que te agobia o qué?
Lo del código fuente.
Claro, sí. No, yo soy más de colorines, formas y demás. A mí eso me agobia un poco.
Please mute yourself if you are connected online, please. So, okay, this container is somewhere in Africa, since and we can see the others. We have, as I mentioned before, of geofencing. That means when a container arrives or leaves a specific area or company, for instance, we have Los Angeles here for this container, or Piraeus for these containers. And finally, we have the door opening. So we can also see when the door of the container was closed or open. As this container was open last time, few days, some weeks ago. Okay, so that's all for this case. If you have any question, if not, we can go to the second one, which is the sharing verified gross mass. You probably know exists international regulation that requires that any full container has a verified gross mass before it's loaded in a vessel. Exist different solutions for providing this data. We here in the port are providing an application for this purpose. And you can see here which are the companies participating in this process, and I'm going to say a little bit because in the demo we will see an example. We have first the product audience. They need to register the certified gross mass of the trucks and the trailers because this data is needed for the DCM calculation we will perform later on. Then we have the DCM requester, usually the freight forwarder, but could be also the shipper. They are going to use the DataPorts platform for submitting a request, and later on in the end, they will perform the payment through the platform, and they will get the DCM certificate in order to share it with all the involved companies. And finally, the scale operators, which are offering their services over DataPorts, because when a request is sent, all the involved companies, you will see them later on, which are involved, are able to see this request. And once the truck arrives in the scale premises, and this way, the information will be included by this company in the application. They, of course, will receive the payment also through the. This is the deployment we prepared. We have these three companies I mentioned accessing to the application. We have some functionalities on the backend, including some change codes in order to store and retrieve data from the blockchain where we store the main information. We have also additional functionalities in order to send to the PCS, the BCM, although in the deployment we have today it's not available, it's not real data. So something you will see it's here is an example, but as before, I will show you a later. Yeah. Before that, which are the benefits we see for this use case? The DataPorts platform is providing more added value than existing solutions because it provides, of course, a verifiable and immutable BCM certificate. So, because the data is stored on the blockchain. In addition, it serves as a source of truth because it's providing transparency and non-repudiation. Anyone can modify, alter the information, or if they modify it, it is registered. And our plan for the next months is to replace the solution that we are using currently in the port with the one that we have developed during the project. Okay, so let's move on to the live demonstrations. So we can go here to the tab. Let me open. Sorry, faster. I prefer some data written. So we can see here in the vehicles view all the registered vehicles. We have here 9,000 trucks and trailers. You can see the main information is the weight and the tank capacity, which also affects the BCM calculation. And each company, hardware company can register their own trucks and trailers. Then we will go to the request, BCM request tab. You can see it's remove the filter. Takes some time because there are 150,000 requests. We can see all the registered BCM requests. Some of them are finished, others processed. The best way to proceed is creating a new one. So if we open new, click to open new, going to copy directly data a bit faster. We can select a track. We automatically include the weight. Trailer, can select level here. Can add a tracking number. We can create a real container. Faster, I will create container one. Select a simple line. We can create, for instance, select the carrier. The BCM that is already performed and the scale, and we can save it. And in the moment, we can see here for BCM requesting status requested. At this moment, as I say, all the companies that I mentioned in this request are able to see in the platform, depending on the roles, this request. And one of them will be the scale of vehicle. So once the BCM goes to the premises and it's 12, they can go back here and add the weight, for instance. So now we will be able to see it is the weight request that is in this case the status is requested because as I said it's not connected right now to the PCS and until this data is sent, the certificate is sent, the status remains as requested. And that's all from my side. I don't know if you have any question because things that will go directly to the meeting. Okay.
Hello, everyone. I'm Tserga, and I will present you the applications that were implemented for the Port of Thessaloniki, alongside with my colleague, Mr. Valenciaport, and Mr. Zerzelidis from CERT, who can handle all technical questions, if there are any. So, our first application regards our greatest profit center, which are the containers. It's called the Container Pickup Application. The scope was to have unified information from a number of systems so as to be able to provide the container status, to provide a new way to our stakeholders to complete the business cycle of the container discharge, and ultimately support the whole ecosystem to optimize their processes. The data sources that were used are the container release order request that comes from a shipping agent, data coming from the digital operating system, track appointment and visual notification. This is how the architecture looks like, the main actors and interactions among the different components. I won't stay too long to this slide because most things are probably explained so far. The benefits are that we can now have timely and unified information from a number of systems that DataPorts utilizes. Utilizing the blockchain component that provides for safe and secure exchange among all supply chain parties, acts as an immutable single source of truth for all transactions, and bringing the all more wanted transparency in the city sector. And ultimately being able to provide reliable services, delivering value to all our stakeholders. So we have prepared a video for you as a demonstration. We chose not to the real life demonstration so to avoid any problems or issues. Do you think this one? I think.
Yeah, probably point out some things while we did right. Yeah, the idea is that because it involves plenty of steps to be showcased, it was very, very dangerous because with the live demo, because anything, there's many steps and many actors actually. We want to show all the actors involved. So instead of having like 5 browser windows open. And yeah, because there's plenty of stuff to show from all the interested parties, it's probably going to be fast one, so brace yourself. The certificate.
Mute us.
I thought that we wanted to mute it to avoid feedback issues.
If only one has to be.
If I do it with the laptop, there should be.
Okay, if it's not one.
have been listening to all this time.
Sometimes someone accidentally like this.
It's 1 minute ago.
Right, now, let's skip this. Right, yeah, this is the step where they fill in the containers, the containers details for the request, and this is pending. So, yeah, this is where the THPA approves the request. As soon as it gets approved, it gets a permit number. So I get one out. And this is obviously registered both in our systems, THPA, and gets sent back as a notification to the shipping agent. Yeah, booking state is not booked yet. Because what happens is that when the shipping agent created the request, they also defined which tracking company is going to be picking up the container. Right? So this is accepted now. It's accepted with this permit ID. Now the tracking company has received a notification that for your request about the container is designated them as the ones to pick up the container. So they get notification over here. You've got a new one, a new permit ID for this container. What they have to do now is log on to our system to create a booking through the booking system. But they just define that, hello, we are this company, we're going to pick up this container. They issue the permit ID for security. And they actually book a slot so that THPA knows when to expect them. This is when the booking is created. It is about this container that I showed you. So back to the shipping agent now. They can see that the request that they sent and accepted, now its status has changed from accepted to booked by tracking company 1, which they designated. There you go. Where is it? Tracking company 1. Okay, for this container. So in every step that takes place, both the shipping agent and the tracking company get an update, and the status changes all the time from pending to booked, accepted, and you will see the next steps as well. So the shipping agent sees the courier, how it went, and the actual booking, because it is a booking that was made by the tracking company, but of course, it's about the container of the shipping agent, so they will know that as well. And the tracking company, even though they made the booking to our systems, it was also sent as a notification to the platform, and they see the balance platform as well. So you should send containers and permit ID and all the details of the container. Now, this we can't show this because it was an actual, like traffic leaving the port, call it gate out. And as soon as this happened, as far as we're concerned, the whole cycle has closed because the container has left the port, and we see this as completed. So there's nothing more to be done. The shipping agent see that the whole thing has happened. It was booked, the truck arrived, picked up the container, and left. Okay. So the booking request as well will appear as completed. Nothing over there. Okay, container. Booking status completed here, so there's nothing more to be done. And as an information, also the tracking company sees, actually it's exactly the same information as the shipping agent, same thing to be checked. So you see, we're tracking company here, same booking has been completed. So everything's finished. And everybody can actually follow the whole process step by step in each status it takes. And they can see exactly what's happening and when. The CPU case.
Thank you. Okay.
So let's proceed with the second application that's called analytics. The scope for that was to increase our relational awareness, and optimize the use of our resources, and assist our stakeholders to optimize their processes. Again, the architecture looks like this. You can see that we have differentiated among the different groups of users, the ones that they have credentials and log on to the DataPorts solution, and any member of the general public who can log on to the public web frontend. The data sources that are used are data coming from the terminal operating system, the track appointment system, the gate access system, from the statistics application, mobility data offered by OTE, traffic data coming from sensors all around the city offered by the Hellenic Institute of Transport, and parking spaces. The benefit is that we finally have a platform that contains data coming from different sources and entities. We can optimize the use of our resources by utilizing the AI component who provides for advanced analytics and predictions to the diverse users of the portal. So again, a video for you, then the application. Now we'll have to speed up things because we have dead time in the video. So as soon as the user logs in, a THPA user, when he clicks on the analytics menu, he's presented with these tabs. The first one is called vessel visualization, where its icon presents the vessel in the port, the lines present the time it spends in the port, and the box presents, the working hours are presented as the box. By clicking in a vessel, you can see on the right vessel information. The graphs underneath, the pointer, this one? No. Anyway, the graphs underneath. Okay, vessels per time or per cargo time. While at the bottom of the screen, we have a plot bar that presents the number of vessels in the port each day, where the user can filter the data, and a selection of outliers, where he can select the range of the vessel that he wants to investigate further. So then we move on to the prediction tab, where, Greg, could you pass it down a little bit? Bring.
Sorry.
That's what I didn't want to happen.
Yeah.
Let's bring it to 2023 or something. Okay, so by filling in the date and submitting the query, the results are the table is filled in with the vessels, the type, the cargo it carries, when is the estimated time of arrival, how much time the mooring will take, and how much time the whole port works will take us time. By clicking on vessel, we can see the specifics of the vessel, how many containers carries, how much weight, and on the right side is the prediction for that specific vessel. So we can have 3 times turnaround, mooring, and by average, min, max, and when everything is expected to be complete. Then we have another way of getting the data, it's called a custom prediction. The user has to fill in all this data that are required so that the model can predict based on the actual amount of cargo that is expected to come on the port. As soon as he submits his query, the table fills in, and again, we can have the turnaround, mooring, and work time for that specific vessel, for that amount of cargo, for that day. By clearing, the form is clear, then he can move on with another prediction. Then we have the vehicle track tab, which presents a map of Thessaloniki, of the port, and nearby areas. The 2 cycles represent the gates of the port. By clicking on a specific date, we can see on the right side the bars that present the amount of traffic for that specific date and time. And in the lower part, we can see the tracks in the port per day. The lighter blue line represents the actual bookings, where the blue line are the actual passes tracks, the actual tracks that this happens. Each node represents day, and by clicking on its node, we can have a prediction for the following 10 days. Then this tab, if the user wants to dig a little bit deeper and see what's the synthesis of this traffic, or what kind of vehicle spends how much time in the port and makes that, it wants to make that correlation. You can see in the upper graph the time intervals from 1 to 5 hours, from 30 minutes, 60 minutes or something. You can, of course, choose a month, a day, and a time for that. And by clicking on a bar on the low, and second graph is presented, where you can see the synthesis of that category of vehicles. Okay, and now we have the capabilities for the public. As soon as they access the public web front end, they are presented with a map that shows the mobility code in every state and region with absolute relative numbers. You can see the choices here on the right. I cannot see the pointer. Anyway, absolute numbers meaning the actual people who are using their cell phone at the time. Relative meaning how low or high are ADT's mobility given an average. And COVID is, well, as we RPO said in his first presentation, is since we wanted to provide something for the general public, since DataPorts make its kickoff right when COVID kicked off. So, okay, let me ask that. Just a little bit back. Can you a little bit back? Thank you.
Whereabouts?
Thanks. You can see the areas colored.
Just to give you, I thought just to give you time.
So you can, by choosing COVID thresholds, you can have these nodes colored by, differentiated by color. Red means, of course, that the area is congested and should be avoided. Orange means that it's starting to get full, while green means that it's safe to wander in the area. By using the slider under the map, you can the user can sort and see whatever data interests him for that day or for that month, etc., etc. There is another choice here, please. Yes. Nice. With that time again. Yes, thank you. In the average mobility choice, okay, we will wait for the map. Go. So we have the map presenting the average mobility in every district cell coordinates and a bar plot that shows the average mobility for a specific hour of day. Again, the user has the ability to select and sort his data for the time interval that he's interested in. And then, okay, so we. Okay, the average traffic detection is a map presenting the traffic the traffic from the city, the average number of vehicles that are for a specific day and time of an hour percent on month. If we click on the bar, we can see then we have the past travel time, where we see the map and all the routes broken down. By selecting a specific path, a month and a day, you can see the graph on the bottom changing, which presents the duration in minutes, so as to traverse that path.
Sorry about that. What are those last bits with
Live events,
sorry.
things happen.
Yeah. This. That's
And finally, a visitor or a professional or anyone who wants to come in the port or around its premises. He has the capability of investigating whether he can find a parking spot. In the first graph, he can choose to see with the parking that he wants to park in. And he can see these doors that stay. Sorry for that. Hold it. It's okay.
Yeah.
So it shows the visitor that stay parked in the port's parking spots, and the smaller chart underneath, you can use it to adjust for a better analysis. While on the right side, you can see a bar chart that shows the other visitors per hour and day of week. So I think that's about it. Sorry for the issues, but doing it live would be really much worse. Just to really try that. So that's
Lots of information to share, so.
more or less it. If you have any questions, we'll be glad to answer. Go on.
Ladies first.
Thank you.
I'm Héctor, and I'm going to present the last slide in this session. Until now, we have seen how DataPorts has improved some scenarios at the ports of Valencia and Thessaloniki. But now let's think about the platform as a tool not only for port authorities, but also for companies that want to benefit from the features that the platform offers. So, in this project, we have integrated DataPorts with 3 applications of the Position Port Solution ecosystem that are using lots of ports. We have integrated Position PCS, that is a community system. We have integrated Position Management, that is an application for management of ports. And finally, we have integrated Position Operations, that is an application for the management of the vessels global ports. All these 3 applications have been developed for the same company, obviously, but as a company that has been collaborating with ports for the last 30 years, it happens that these applications were made by different people at different times and by different clients. As a consequence, it means that there is not a common data model for all of them. And although we have, of course, some mechanisms to share information between them, each of the applications have their own data sources. With this project, what we wanted to achieve is to have an easy way, a standard way to get these events of what's happening in these applications and to be able to share all this information. As
it has a bit of delay because I'm using Teams. Okay, so what we did in this project in that time is to cooperate with the Port of Baleares, where they already have these three applications. We have subscribed for data of vessels of position operations, and we also upgraded to the other two applications, management and PCS, in order to get all the user interactions of this application. All this data is sent to DataPorts, and then using DataPorts, we have built a new application that is going to use this platform to get all the data from these applications directly from the platform, no matter the source of these events. So, in order to have a better review of which are these events that we are able now to share, you will see that there are very different kind of events. We have related with the vessel, the port entry, the exit of the vessel, and then when the vessel enters the berth or exits the berth, if it enters the anchorage area. On the other hand, we have the position management, where we have integrated the changes in the estimated time of arrival or departure, when the port call starts or when it ends, and also where the port call is authorized or the carbon manifest is activated. And finally, on Positonia PCS, we have focused on the request management. This means about the resources, for example, like water or electricity, but also other requests like the access to the port or the request for waste removal or the subsurface page. Once we have this information in the platform, this other application will let the user subscribe to topics related with these events and to decide how they want to be notified about all this. So finally, summarizing, which are the benefits? In short, you can say this information have provided us an easy way to share information between these applications. But also, now we can share this information not only with more users, we can reach more stakeholders. For example, we can reach now external users that are not part of the Position ecosystem. And finally, you saw that there are lots of different events. So it is not easy to say we have improved this scenario or this one, because we have events for very different kind of situations. So it's like we are now able to improve lots of processes we manage. Now I'm going to show you a short demo of what does it mean. Okay, let me explain it a bit. I'm going to focus on an easy follow, in a demo that is easy to follow. Okay, we're going to focus in the request. We have two different applications because in PCS, that is the application that the user, where the users can manage this kind of resource request. And then we have also notifications where you will be able to send what do you want. And finally, there are two kinds of users involved here. We have the vessel consignee, that is the one who makes the water request. And finally, we have the port authority, that is the entity that has to approve or deny this request. I forgot to say that, of course, a vessel consignee is interested in being notified when a new request is done. And the vessel consignee, that is the one who makes the request, wants to know as much as possible if the request has been or denied. So now I'm going to sit down because I'm going to with the demo live. Like demo. I have two different browsers here in order to speed up things. I already log in. Okay, let me. It's two browsers. Okay. So the first browser is the computer of the Port Authority. I already log in the Position notification in order to set the notifications I want to receive. In this case, I am interested in receiving when new request of water ads. So this is my default destination, let's say. This is where I want to get my notifications. And now I'm going to create a new subscription. Okay, I have a lot of topics already defined because of the events that we already integrated in this project. And I'm going to pick the water supply request. Now I can select how I want to subscribe for this topic. I'm going to select organization because as a port authority, let's say that the Balearic Port Authority has managed 5 different ports, and I want to get notifications from all of them. So I'm going to subscribe as an organization, that is the Port Authority level. And then I'm going to pick how I want to be notified, I choose email, and by default, I have this because it's the okay, now I have a subscription for water supply. Now I'm going to open the same application, but as a vessel consignee. Again, I have my default destination, and I'm going to subscribe. In this case, I want to subscribe when my are denied or accepted. So I'm going to create 2 subscriptions. The water accepted, and in this case, I just want to get notification about my request, not others. So I'm going to pick stakeholder because this will make that I only receive the notification from the events that are somehow related with me. I'm going to add destination, okay, I made and I deploy the app. I'm going to create another subscription. Now is supply denied. Again, stakeholder. Destination. So I have here my 2 subscriptions. Now I'm going to move to PCS in order to make the request and then to manage. So as a consignee, I already log in and went to professional services, water super energy. I'm going to create a new water request. So I'm going to pick one of my vessels. And I'm going to create a water supply. And let's say I ask for a lot of water. Okay, so I have created a request, and if everything went good, now I can go here and check for my notifications. You can see that a new notification has been created. Of course, this is just for Iturria. This is just for you to know the notification that has been created, but it has no sense to go here to check for them. But the good part is that you already receive an email that says that a new request has been made. Okay, now as the port authority, I know that I have a new request. So I come here, I have this new request, and let's say that it's too much water, and I'm going to deny it. And I say, please, maybe, okay, deny. So then, as a vessel consignee, if I return here and go back here, I will have a notification that refers me that my water supply has been denied. And of course, there is a new email that warns me that, okay, you have to really please go again to the application and create a new request. So that's, we can speed up things, and with the initial demonstration, this is a really simple use case. But now imagine the different kind of events that we are able to share potential of this. And this is just an email, but we will be able to send WhatsApps or webhooks or whatever. And that's all from my side. It was yes. Very to keep it.